Hi everyone. Today I'm going to talk about my new lecture about it's related to optimization and deep understanding of input bound and CPU bounded in data engineering, software engineering, anything. So we are going to cover what is input output bound, what is CPU bound, and then the key difference on the two. So when we talk about input bound, so we are going to talk about so input bound basically is a rely heavily on input output operation such as file transfer or data transfer from one system to another system or data injection from one system. And the second part of this one is like slow disk network operation or the bottleneck example loading data from the database large file system. Okay. So when we talk about CPU bound, so CPU means it's related to memory, and when we talk about memory, that is computation. So depending upon processor speed for performance, intensive computation limit of speed, example of data transformation. So first part is for data injection, and this is for data transformation and complex aggregation. So we are going to cover these topics. So these are like, you know, IO bound, what's the CPU bound, CPU bound, currencies. So then let's talk about first one, as I said, overview of this one, why it's important, why we need this one. So this is like a difference between the overview. We are talking about this one. Impact on performance and resource users. So let's go into overview for this one, number two. So when we are designing optimization software, it's important to understand the difference between IO and CPU. So each type of utilize different computing resources. Understanding of these, distinct can help to optimize resource usage, improve the performance. They can improve the performance. So sometimes I want, the very. So we write a program to solve the problem, and the program utilizes various resources for the computer system, which they run for it, and the program running on the machine will be broadly required. So this is one of the program when we run, it requires CPU, it requires memory, it requires network resources, it requires disk storage. So one program is these things, right? And to optimization approach will be like IO bound task and the CPU bound task. IO bound is a efficient resource management. Is for CPU bound is for the parallel processing and multithreading. Okay. So this is the key components. So key component we talk is here like for any computer resource or CPU is central processing unit and it handles the computation and the execution of program. Memory. Memory we talk about RAM is a temporary store the data for the CPU access. Networking is the facility for data exchange over the network. Disk storage is provided for permanent storage for the data. So these are the things which we talk here, right? Understanding. So this is the things which we discuss, like IO and CPU. So what IO is required, input output operation required, what is central processing required, some required like threading, some required the efficient resource management. So now we are understanding CPU bound and IO bound. Okay. So CPU bound versus IO bound. Then we CPU bound, IO bound, and only two things. This is unutilized nodes, and I haven't not make anything here. So primarily limited by CPU speed availability. CPU one is basically availability, CPU and speed. And the characteristic for this one is like intensive user calculation. High CPU usage, minimum of the resources depending upon CPU power. Okay, CPU one. So let's learn about CPU. CPU one is one of the finely limited speed availability of CPU. These tasks involve the heavily computation and require significant amount of CPU time and performance. Right. So this CPU means intensive computation. High CPU usage depend upon processing power. Improve the multi-core processing. If you improve the CPU, it will improve the multi-core processor. High CPU usage is finally utilize CPU, minimize use of other resources. Example, of cryptographic processing and simulation. And intensive computation, so say cryptography, mathematics, and machine learning. High CPU usage found extensive living other resources. And example, Yeah, to better understanding, let me give the CPU like so image or video processing. Tasks like resizing of image, encoding video files, relying intelligent CPU processing. Machine learning model, training complex model, is a neural network. It requires a lot of computation, often CPU and GPU. Scientific calculation like large calculations such as weather forecasting to optimize this one. So first thing is very important for parallel processing. We break data split task into the multiple CPU core using multi-threading and multiprocessing hardware. So you can increase number of hardware, parallel multi-compatibility tasks, efficient algorithm, and then the third one is. So first one is like parallel processing is for multi-threading, multi-processing. Second one is you increase hardware. Third one is you increase your code, right? Now let's talk about I/O. So definition of I/O task is that primary limited of the speed input-output operations such as reading and writing data into disk, accessing database, making the network call, right? So this is the features. Primarily limited by speed, input-output operation, intensive input-output. Example: disk read and write network required, DB queries, low usage, CPU wait while the other output is complete. Depending on the speed, improve the faster storage, reduce the weight limit, so improve this one. So intensive input-output operations involve the frequently read, write disk, network database require low CPU usage. Task is typically little CPU while the waiting for the input-output operations. Depend on the IO speed, perform the improve the optimization data transfer speed. Example: database queries. Large database require extensive read-write operation, which often slows CPU process. Okay. So network request, downloading, uploading file, making it take for and fetching. This is the remote server. File output, reading and writing large file, especially when data is stored in the slower storage devices. So optimization. First thing is do asynchronous. Is keep use asynchronous. Programming like async await to handle IO operation without blocking the program flow. Passing, store the frequency access data. In the cache, reduce input output batch processing. Process data batch and reduce the frequency input out, especially network and database operation. So these are the difference: input output bounded versus CPU bounded. So aspect primary limitation, input output bound is speed, disk, network, or memory. So limited by these are things. And CPU bound is the CPU processing power. It's limited by the CPU power. So the main is here. And the resource is this. Input output bound use low CPU but high input output. But CPU bound use high CPU and low input output. Example, and I said this is file reading, writing, network call, database access. And CPU, image processing, cryptography, model training, machine learning, so on. Optimization focus here, faster input output, asynchronous processing. Faster CPU, parallelism, optimization algorithm. Execution is strategy, which is asynchronous, non-blocking execution, multi-threading, and multiprocessing. So now the next part we are talking, like if we taking a lot of resources, and then we need to find our IO bound or CPU bound, and then we need to fix it. To understand whether the program is IO bound or CPU bound, and for choosing appropriate profiling. Yeah. So first thing we need to do data profiling or the code level. So this is for IO bound tasks tool like iOS, TAT, or disk states, Linux help to monitor IO. While network connectivity tracks the network latency and throughput. CPU bound tool like Top, Xtop, and then for Linux Task Manager and Windows, these are the tools which we can use, right? Like tool POP, Top, Xtop, iOS, TAT, disk stats, something like that. The next one is code and so these are two things for profiling purpose we use, right? Let me. So guys, this is the article I have written, and I will give you link to my this Google's in the comment section. You guys can read. So code level, I about the code perform network request, database call and file system. Is it a reading file? CPU bound code perform the intensive calculation. So this we need to check. Handling input output and task in programming. I about So in programming support like Java, Python, all the things for IO bound, as we said, we use asynchronous. So basically, it's asynchronous. So we need to type is asynchronous. This is the module async co and AIO HTTP, and then you need to type async definition fetch data URL async with uh, HTTPS call async with session URL async. So everywhere is async, and then here is wait, right? This example called the handle of asynchronously, allowing multiple requests by processing concurrently without, asynchronous means we don't need to wait for another call, and it can run parallelly. CPU bound tasks are often best handled for multi-threading if the task is silently IO for multi-processing if the CPU intensive. Multi-processing, multi-threading, there is two keywords. So multi-threading used for IO, multi-processing used for CPU. Example of multi-processing for the CPU, multi-processing. So multi-processing used for CPU. So this is for CPU. So multiprocessing, we use multiprocessing, then we use pool, then the heavy computation, something, and this is the how pool we are used. This is an example. When prioritizing IO versus CPU for IO amount, focus on minimizing wait time by optimizing data transfer rates using the faster storage, a solution is faster storage is like SSD, and reducing the need for speed. Okay. Implement asynchronous processing, maximum resource utilization. For CPU bound, we increase CPU usage for the parallel using the multiple core and choosing the region. For the computationally heavy workload, offloading, this is like hardware like CPU, FPGA, Vega, and acceleration. This is the things you can see that you have to GPU bound. Now program which this is what I said, like heavy computations and so on. This is, I think, example. If you want programs and so on, you can read this one. I'm not going to read all the things. And this is an example. And some of the multi-threading example I have given here. It is in, Java, but you guys can use Python. So I will change here to Java, right? Yeah. So this is a class, some task, and extend to paid class, and some class has some operate. It's the same name. It's called operator, or in Java, it's not method, but operators, and then void runs, and long get some public static void when then we are calling to the some task is here. This is some task, and this is some task, and it start, and this is like multi-threading. IO-bound programs is for input-output operation in Python program, which I have given, right? And this is the example, and which is I have gone through. So please, guys, like and subscribe my channel. Thank you for watching. This is very important topic, but this has a lot of things, so I have covered the most of things.